maximum. What actually happens? So this is the, so initially what happens when you give velocity, there's a block B, so this will start elongating. This will have say some velocity, say VA1, spring will get elongated kx1, kx1. Because of this spring force, this will start moving, so this will acquire velocity VB1. Like this, the velocity of this now it keeps on decreases no? After some time. Velocity of this will keep on increase, velocity of this will decrease here. So both will have common velocity. There's a very basic fundamental one. Please all of you do try to understand. Drawing diagrams not that easier. Yeah. So this is the, finally what will happen? We'll get this one. So they will have common velocity, I'll say. And the elongation of the spring will be maximum. This is maximum elongation. Already we have discussed. At maximum elongation compression, both will have common velocity. Will I agree this? So this is what happens. Very next moment again, what will happen? The velocity of block B will be greater than that of block A. VA2, this will be VB2. Here also there will be elongation, but this elongation x2 will be less than xm. Xn will be less than xm. So where maximum elongation is present? Of altogether, the maximum elongation is present at this particular point. At maximum elongation, what is the situation? Both are having common velocity. Okay, agree this? So there's a one basic idea of the total problem. Okay, now next after this, what will happen? The velocity VB2 is greater than VA2. So what happened to the block? The spring what happened now will come out of elongation. Again, they'll attain natural length. The spring will have natural length. Tell me at this particular point, what should be the state of A and B? What was V relative? What should be the V relative now? What is V relative? Equal to U, no? What is the relative speed equal to U? Now the relative speed should be equal to U. For the relative speed to be equal to say V naught, for the relative speed to be equal to V naught, tell me like what should be the state of this? Natural length, initially also it's a natural length. X equal to 0. So this should be have velocity V naught. Now after this what happens? The spring will undergo compression. Again the sequence will continue. So now spring force will act Kx3. So call VB3. Spring force will act in this direction. So now it's a compression. Now the velocity of this block will increase. The velocity of B will keep on decrease. After compression, open maximum compression. Again at maximum compression, what we'll get? Both will have same again common velocity and compression will be maximum. Again this, it will come out of maximum compression. So immediately will not get natural length. So there will be a compression called X4. X4, this will have velocity VA4. This will be velocity VB4. Now what is the velocity? VA4 will be greater than VB4. This will be compression. I think spring force is showing. After this, again will come natural. This sequence will occur here. So at maximum compression, look at the condition. Both will have, the velocity should be in this direction. Both will have common velocity. So what is the basic idea? At maximum elongation or compression, what is the state of the ends of the spring? They must have common velocity. And what that common velocity should be equal to? How to Judge this. I'm giving total sequence. Try to see. This what happens here. You have everything in front of you. Now let's calculate the center of mass. So center of mass, this is will be somewhere here. So what is the velocity of center of mass? mv naught plus 2m 0 by m plus 2m. No? What is the velocity of center of mass? V naught by 3. In all the sequence, what happened to velocity of center of mass? Should remain same, no? Everywhere here, what is the center of mass? S. It will be moving with a velocity vc. What about here? Moving with a velocity vc. Everywhere the center of mass will be moving with the same velocity. Even here also. Now, this is very important idea of this one. And now let's calculate the common velocity. Can we apply conservation of momentum? Yes, because net force on system along x-axis 0. So therefore, mv naught should be equal to mv plus 2mv. No, what is the mass of this 2m? So how much we are getting? V naught by 3. So at maximum compression or elongation, what is the state of the blocks? Shall I say they will have velocity of center of mass? This is nothing but equal to what? Vc, no? So what is the conclusion? At maximum elongation compression, so what happened to blocks? The blocks will be moving with velocity of center of, not I'm saying speed, velocity. In what direction the center of mass is having velocity, in that direction only the blocks will have common velocity. This is a golden rule. You should not deviate from this idea. Sir, how do you can say? Look at the sequence, everything we have here, no? Look at here. I got the common velocity. Sir, how you brought this equation? From where this conservation of linear momentum. So spring force is acting. Net spring force, how much you check it? Say kx1, kx1. Everywhere you check it. So look at here, everywhere. The net force acting on system. Can you apply between any two positions? Yes, because the net force acting on system is 0. I am taking help of conservation of linear momentum. Can I apply conservation of mechanical energy? Yes, you can apply. Can I find out, sir, VA2? Can I find out X2? Yes. Can we calculate that maximum compression? How to calculate maximum compression? I said one very important thing. What is that? At maximum elongation compression, what is the velocity of the blocks? Will be velocity of center of mass. How to calculate that maximum elongation or maximum compression? I'll apply conservation of mechanical energy. Initial kinetic energy given mv naught square, mv square by 2, 2mv square by 2 plus kxm square by 2. Maximum elongation here. Maximum compression here. And look at that yellow color V I'm giving. So at maximum elongation compression, the blocks will have common velocity equal to velocity of center of mass. So what is XM? Maximum compression or elongation? Both are same. Are you getting the idea? Yeah.
Even in maximum compression, we'll have same velocity, sir.
Yeah, therefore no. Here you see.
V not.
Yeah, equal to VC. We have no everything. V equal to V naught by 3 and velocity of center of mass also V naught by 3. And look at how the V bar of velocity of A and B along the velocity along the direction of center of mass only. Okay, this I think I'm clearly indicating. Please, this is the very important part of the discussion. Leave all the things. You must look at the third and the last diagram, last but one diagram. Okay, fine. And now in C frame, let's do this problem in C frame. In C frame, what will happen to this? I'll take it back. I'll go to the C frame. Now in the C frame, how to do this problem? What was the system given? Velocity V0 and 2m. No? I'm coming to the C frame analysis. I'll retain the initial diagram. So this is what m V0 x is released and that placed on the ground. This was at rest. In the C frame, velocity of center of mass already I think I discussed V0 by 3 it is. And the center of mass of system is here. Initially, this is the situation. This is the block A, this is the block B. Now, let's calculate velocity of A with respect to center of mass. So, VAC. Can you remember? There's one easiest method of finding out velocity of block A is how much? V0. V0 by 3. How much it is? 2 V0 by 3. In the same situation, how the block A will move? Towards right. What about block B? In the ground frame, this is at rest. In the C frame, let's see what will happen. So VBC equal to VB. In the ground frame, it was at rest, no? Put 0. So 2 V0 by 3. So in the ground frame, what is the situation of it? It is moving away. So what is the velocity? It will be how much? VAC, VBC. They are moving away, and this is x equals 0. and whenever C frame comes, no, better put box and show that VC here. Don't show center of mass here. And now what will happen to at maximum elongation? Let's come for maximum elongation. How things will occur here. At maximum elongation, the ground frame. What is the state of the blocks? They will have common velocity, no? And what is that common velocity? It is equal to how much? V0 by 3. This is in ground frame. In C frame, what will happen? According to, suppose you are in at center of mass of system, you are at center of mass, you are in C frame, the blocks will move away. And at maximum elongation, the same situation now you take like this. There is a maximum elongation. And in C frame, how the blocks will appear? Should appear at rest. Will I agree? I should write rest. Why rest? Because what's happening to you now? So in the C frame, what should be the comment? Person, where the person is there on the C frame. Is at center of mass, is on center of mass, is moving. Then at maximum elongation, you see that the blocks are at rest. After this, what will happen? The spring force will act. Again, the blocks are pulled back. So like that, what's happening to the blocks? They are in the ground frame, what will happen? Like sequence rotation. In center of mass frame, what happens? It's very simple. Initially, the blocks will move away. At maximum elongation, the blocks will be at rest. The person in C frame will see. Then again, maximum elongation will occur. Then again, spring force will act. Again, will bring it back. Like that, what happens? In C frame, they're just moving away, come to instantaneous rest, maximum elongation. Then again, they'll approach. Clear this. Natural length. Then again, what will happen? Maximum compression. That maximum elongation, maximum compression again. What is the velocity of the blocks in C frame will be at rest. So in C frame, they're just oscillating. They're just moving away and approaching. They're moving away, come to rest, maximum elongation. Then they'll start approaching. So this was the sequence. So again, at maximum compression, we know how the you can apply in any frame. You can apply conservation of energy. Total energy should be okay. Now at maximum compression, here only let me conclude here. Again at maximum compression, how the blocks will be 2m. We have this diagram, no? There's a block A, there's a block B. The spring force is acting like this. The velocity of the blocks were like this. Maximum compression, no? Now in the C frame, how the blocks will be now? The spring force, in fact, will be acting like this. And what will happen to the center of mass of system? Will be moving. And what is the state of blocks? Will be at rest. So how do you can see velocity of block with respect to center of mass? We know what is this? This V is equal to how much? VC, no?